Welcome, this is Coach Dorf. We're going to continue our discussion about calculus and optimization problems. And we're going to now look at an example of a homework type problem. So in this problem, we have a Norman window, which has the shape of a rectangle surmounted by a semicircle. Thus, the diameter of the semicircle is equal to the width of the rectangle. If the perimeter of the window is 30 feet, find the dimensions of the window so the greatest possible amount of light is emitted. So first, let's draw a picture here. So we've got a rectangle for the base of the window, and then on top of it, we have a semicircle. All right, so that's what a Norman window looks like. And let's call the base, this length here of this rectangle, X, and this height be Y. So X equals base of rectangle, the length of the base, and Y equals the height. So we have to look now, we have the semicircle, so we need to get some information about the semicircle. So this diameter here, so the diameter of the circle is going to equal X, because that gives us the top of the rectangle. So what's the radius? The radius of the circle, which is going to be R, is going to be half of that. So that will be 1/2 X. And I can think like that right here, that part there is going to be 1/2 X. All right. And what do we are given that the perimeter of the window is 30 feet. So we know perimeter equals 30 feet. Now, how do I find the perimeter? So the perimeter is going to be the outside. So I'm going to draw that in red. So it's going to be this side plus this plus the top, that semicircle on the top. Let me use another color then. So let's just add these sides together. So this side there is Y, perimeter, which is 30, is going to equal Y, right? That's that Y there, plus X at the base, plus a Y on the other side. And now we have to find this curved part at the top. The curved part is half the circumference of a circle. So we get half the circumference of circle. Well, the circumference of a circle is 2 pi r. So half of it is going to equal 1/2 times 2 pi r, which is going to be pi r. And what do we know about r? Remember, r was 1/2 x. So this is going to be 1/2 pi x. So this is going to go in here for this amount. So then we're going to have perimeter, which equals 30, is y plus x plus y plus 1/2 pi x. And I can simplify that, right? Combining the y's together, I'm going to get x plus 2y plus 1/2 pi x, and that's going to equal 30. So this is going to be my equation I have, and I've got my variables. And for me, that's step one in solving these optimization problems. So the second step is to find my function that I need to maximize or minimize. So what am I trying to maximize or minimize? It says I'm trying to find the dimensions so I get the greatest amount of light. So the light would be the area of our window. So this is going to be maximize area of window. And so we have to figure out what the area is. Well, the area is going to be the area of the rectangle plus 1/2 area of the circle on top. So area is going to equal, the area of the rectangle is going to be x times y, because x is the base, y is the height, and the area of the circle is pi r squared. So it's 1/2 pi r squared. We have xy plus 1/2 pi. And what's r? Going back to the very beginning, up here, let me use red as a different color. Maybe I'll use blue, sorry. Blue here, we're going to take this blue and put it in for r, and that blue is 1/2 x squared, because it was r squared. So I get area equals xy plus 1/2 pi times 1/4 x squared. So then I get area equals x times y plus pi over 8 x squared. I combine the 1/2 and the 1/4 to get 1/8, and then I multiply by pi, so I get pi over 8. All right, so simplifying that, then I get area equals x times y, and now I'm going to combine the 1/4, the 1/2 and the 1/4 to give me 1/8 pi x squared. All right, so there is my function that I want to maximize, but I want to put that in terms of one variable. So what do I have here? Again, I've got this area equals xy plus 1/2 pi x squared. And we also had up above here in this purple here, we've got the equation x plus 2y plus 1/2 pi x equals 30. So we're going to take that purple equation here, and I want to solve for y. So we're going to solve this for y. Solve this, meaning this equation y. And then when I do that, I can substitute that back in here for y, and I can get my area function in terms of just one variable. So we're going to have x plus 2y plus 1/2 pi times x equals 30. I want to solve for y. So I'm going to subtract the x and the 1/2 pi over x, bring it to the other side. I get 2 equals 30 minus x minus 1/2 pi x, and divide by 2. So then I'm going to get 30 minus x minus 1/2 pi x over 2, which I can also write as y equals 15 minus 1/2 x minus 1/4 pi x. All right, so I'm going to take this now and substitute it into, oops, not there. Let me go back. I'm going to substitute it into here, my area formula. So my area formula is going to be just in terms of x's now. I'm going to have x, and instead of putting y, I'm going to substitute what I have in green here. So I have 15x, 15 minus 1/2 x minus 1/4 pi x. And then I've got plus 1/8 pi x squared. And again, all of that comes from this here, came from what we had up here. So we brought that down here, and we substituted in for the y what we had in green. Let's then simplify this a little bit. So a of x is 15x. I'm going to distribute my x out here to different terms. So I have 15x minus 1/2 x squared minus 1/4 pi x squared plus 1/8 pi x squared. And at this point, I can continue to simplify it if I'd like, or I could wait and simplify it later. I'm just going to go ahead and simplify it a little bit more. So a of x is 15x. And then for everything here in red, I want to get a common denominator. My common denominator is going to be 8. So I'm going to have plus 1/8. And so, well, let me not write it that way. Back a little bit. Might be easier to see it this way. So I want to get everything in terms with an 8 there. So I'm going to have minus 4/8 x squared minus 2/8 pi x squared plus 1/8 pi x squared. And then I'm going to take put the 8 in the denominator. And so I'm going to have minus 4x squared minus 2 pi x squared plus pi x squared over 8. And I'm going to do one more. I'm going to do just one more simplification here. I'm going to write this as 15x plus negative 4. And then I'm going to combine these together to get a negative 1 pi. And that's all times x squared. So I factored out the x all over 8. So there's my function a of x. A lot of work to get there, but we're there. So next step now, we have our function in terms, the function we want to maximize, we have it in terms of one variable. So then we do step 4, which is to do the second derivative test and find the critical numbers and then find whether those are max or mins. So I think I take the derivative of this. So the derivative of this is going to be 15 and then plus negative 4 minus pi over 8 times the derivative of x squared, which is 2x. All right. And so I can simplify that a little bit. I'm going to get a minus. So I'm going to take this minus out here and here, take it out. So now I have 4 plus pi. And I'm going to reduce this 2 and this 8 to get 1 and 4. So I now have a 4 in the denominator. And I shouldn't forget my x here. So I have an x right here. And that's going to be set to equal to 0 to find the critical numbers. So all that work we did in part 3 was to help us in trying to simplify it. So now it's a lot easier to find the critical number. So if I bring the 15 over to the other side, I'm going to have something like this. The negatives cancel each other out. And I could divide both sides by 4 plus pi all over 4, but I'm going to multiply by the reciprocal. Let me do that in purple. So I'm going to multiply by 4 over 4 plus pi on both sides. And why do I do that? Because when I do that, then on the left side, the 4's cancel out and the 4 plus pi's cancel out. And so I'm left with on the left side just x. And now when I multiply 15 times the 4, I get 60 over 4 plus pi. All right, so that gives me critical number. All right. And so now I need to see if the second derivative here. So let me go back one. Remember the first derivative was 15 minus 4 plus pi over 4 times x. We got that from right here. We're just bringing that down here. And now to find the second derivative, I take the derivative of that. So the second derivative is going to equal minus 4 plus pi over 4. And that's always going to be a negative number, no matter what I put in for the critical number. So in particular, I could put this in 60 plus 4 over 4 plus pi. And I'm still going to get this negative 4 plus pi over 4, which is less than 0. And if it's less than 0, negative numbers, I have negative. Second derivative, I have 2 negatives there. That gives me my frowny face. And at the very top here, then we have a maximum at this x value, which was 60 over 4 plus pi. Remember now, because we have a negative here, I could put in any number. In fact, let's look at this one. Any number here, I would get a negative. Any values for x, I'd get a negative. It doesn't mean that any number then would be a maximum. It just means that it would be concave down. I get the maximum because I have a critical number. I'm using the critical number here, all right? And I'm putting it in and I get a negative. So at the critical number, I get a maximum. All other x values just tell me that they're going to be concave down. So great, we wanted a maximum, we got a maximum. So now we just have the last step, and that is to answer the question. And going back to the very top here, let's make sure we answer the question. What was the question? The question is find the dimensions of the window. So we need to find what y is. So we know already, we've already seen that x is 60 plus 4, 60 over 4 plus 5. So now what is y? And we're going to use the fact earlier that we found here in green that y was this value, 15 minus 1/2 x minus 1/4 pi x. So I'm going to write that down here. So equals, I've already forgotten that. Sorry, 15, right? Oops, 15 minus 1/2 x minus 1/4 pi x. All right. And so now I'm going to put in this x value in for x here and here. So I get y equals 15 minus 1/2, 60 over 4 plus pi, minus 1/4 pi times 60 over 4 plus pi. This kind of like a mess, but we can still keep working with it. Let's get a common denominator of 4 plus pi. So I'm going to have 15, and I want to have a common denominator of 4 plus pi there. So I have to multiply the top by and the bottom by 4 plus pi. In this term, I can reduce the 2 and the 60 to give me 30. So I'm going to get minus 30 over 4 plus pi. And here in the next term, I can reduce the 4 and the 60 to be 15 on the top and 1 on the bottom. And so that's going to give me minus 15 pi over 4 plus pi. So keep working here. Got this 15 distributed to these two terms. So I've got 60, 15 times 4 is 60, plus 15 pi, minus 30 from here, and then minus 15 pi, all over 4 plus pi. So y is going to equal minus the 60, and then minus 30 will give me 30. And oops, I have a pi here. That was 15 pi. And the 15 pi, minus 15 pi, they go away. And so in the denominator, I have 4 plus 30. And so that's my y value. So the dimensions of the window are x equals 60 over 4 plus pi and y equals 30 over 4 plus pi. All right, tough problem. A lot of weird numbers there, but that's how it works out. Hope that helps you. Have a great day.